Hello children, this is your Kirti ma'am. As part of the board revision for CBSE Grade 10, today we are going to revise the whole chapter Acids, Bases and Salts. So let us first see what are acids. Acids are sour in taste. Okay, when you taste them, okay, they are sour in taste. And acids turn the blue litmus paper into red. What do? They turn the blue litmus paper into red and they dissolve in water to give H plus ions. Now you people already know that acids are sour in taste. They turn the blue litmus paper into red and they dissolve in water to release H plus ions. Okay, we'll quickly see what happens here. Okay, I have water here. Okay, now when I take an acid, okay, you can take any acid. Let me take HCl here. When I dissolve the acid into water, what does the acid release? It releases H plus ions into the water. Now, if you see here, this is a very important thing. H plus ions are very unstable. H plus ions are very unstable. So what do they do is, and they are electron deficient. They don't have electrons with them because hydrogen has only one electron. That electron also is not there with hydrogen. So it is an electron deficient species. Because hydrogen is an electron deficient species, when you put it in water or when it is in water, it sees the lone pair of electrons on oxygen. So it goes and attacks on the oxygen's lone pair, forming what? H3O plus. This is your hydronium ion. The positive charge should be on oxygen because oxygen is donating its lone pair of electrons to H plus. So whenever you put acid in water, what happens? Acid dissociates to give H plus ions. As H plus ion is an unstable species, it attacks the lone pair on, okay, lone pair on oxygen which is there in water, forming hydronium ion. What do you call H3O plus as? Hydronium ion. So this happens when you put any acid into water. Okay, it will not exist as H plus. H plus will combine with H2O, giving your hydronium ion. This is very important because sometimes in exam they ask acidity of this acidity of the acids or acidity of any solution is due to the formation of hydronium ions. Clear with this? Okay, now if you see here, you understood now they dissolve in water to release H plus ions. I told you about the fate of H plus ions also. What happens to the H plus ions? When you put acid in water, they form hydronium ions. See that the positive charge is on oxygen. H3O plus is called hydronium ion. If you want the spelling, it is hydronium ion. Now, if you go with the properties of acids, as I told you, acids have a sour taste. They turn blue litmus paper into red. Acid solutions conduct electricity. Okay, how can you say that acid solutions conduct electricity? In chemistry or in solutions, the conductivity is due to ions. And in the solution, you have ions, you have H plus ion, you have Cl minus ions. Okay, so because ions are there, you people know ions are charge carriers. Okay, in solutions, ions can conduct electricity. In solutions, what are the species entities that can conduct electricity? Ions. Here ions are there, so acid solution can conduct electricity. They release H plus ions in the aqueous solution. Clear with the properties of acids? Now let us go with the types of acids. Acids are mainly classified into two types based on the occurrence. Okay, there are different classification of acids. Here basically we are classifying acids based on their occurrence. On the basis of occurrence, you have two types of acids, natural acids and mineral acids. What are natural acids? When the acids are obtained from natural sources. Clear? When the acids are obtained from natural sources, I call them as natural acids or organic acids. Usually what are the natural sources from where you can get the organic acids? The natural sources are usually plants and animals. Okay, that is the reason. Okay, instead of calling it as natural acids, we normally call it as organic acids because the source is usually plants and animals, and plants and animals are organic matter. That is the reason whenever the acids are obtained from natural sources like plants and animals, what do we call them as? Organic acids. Now you have example methanoic acid, which is also called as formic acid. You have your acetic acid, and you also have your oxalic acid. Okay, so these are your no, natural acids. These are your natural acids. Now what are the sources of these acids? We will see. If you want to see the oxalic acid structure is given as C2H2OH. Oxalic acid is a dicarboxylic acid. It has two carboxylic acid groups. It exists in this form. If you combine and write the formula, it is C2 H2O4. This is the formula for your oxalic acid. Methanoic and acetic acid you already know because you study in this chapter carbon and its compounds. Okay, now let us see the source of these organic acids here. Okay, because I told you organic acids are usually from plants and animals, so you have to know the source of the organic acids. Now, these questions repeatedly keep coming in the board exam for MCQs. So please by heart the table. I'll put the PDF in the description below. So please go through the notes so that you can again go through all these points. What is the source of your acetic acid? It is your vinegar. Okay, source of acetic acid. Acetic acid is your ethanoic acid. Ethanoic acid is the IUPAC name. The common name of ethanoic acid is your acetic acid. Then you have ascorbic acid. Ascorbic acid is, you get ascorbic acid from guar or amla. Citric acid, the source of citric acid is lemon, orange or any other citrus fruit. Now comes the lactic acid. Lactic acid, usually we write milk, but the correct answer is what? Sour milk. Sour milk or curd. Methanoic acid, the common name of methanoic acid is formic acid. Why do you call it as formic acid? Okay, because the source is ant. Okay, because we get methanoic acid from ant sting, methanoic acid is very commonly called as formic acid. So what is the source of methanoic acid? Ant sting and nettle sting. Okay, oxalic acid, what is the source? I have shown you the structure of oxalic acid also. COOH dicarboxylic acid. It is tomato. Then tartaric acid, what is the source of tartaric acid? It is your tamarind. You need to by heart this table repeatedly. This table has been asked in the exam in the form of MCQs. And all these acids are organic acids. Their source either being plants or animals. Okay, plants or animals or any other natural source, okay, which exists. Now when we come to the mineral acids part, okay, now when we come to the mineral acids part, mineral acids are prepared from minerals. Now from where do you get the minerals? Minerals, we usually get it from the earth's crust. Okay, your minerals you usually get it from the earth's crust. So acids that are prepared from minerals are called mineral acids. Minerals are usually, we take minerals from the earth's crust. You know, earth has a crust, mantle and core. Okay, so usually we take the minerals from the earth's crust. Okay, they can be taken either from minerals, okay, or you can, they might be man-made, laboratory made acids also. Okay, if they are man-made, or okay, if okay, they are usually we get them from the earth's crust. But nowadays there are some synthetic acid which are made in the lab. Okay, usually what are mineral acids? Acids that are extracted from the minerals. And where are these minerals obtained? In the earth's crust. Clear? Now, what are the important examples of your mineral acids? I have my HCl, H2SO4, nitric acid, carbonic acid, and your phosphoric acid. Now, even in, see, if you compare, listen very carefully, if you compare mineral acids and organic acids, mineral acids are stronger acids. Okay, if you compare mineral acids and organic acids, mineral acids, okay, they are stronger acids when compared to your organic acids. Clear? Mineral acids are stronger acids when compared to your organic acids. Now even in mineral acids, you have strong and weak. Even in mineral acids you have strong and weak. In the mineral acids, okay, we take few acids under the category of strong acids. Clear? What are the 5 mineral acids you should remember? Hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, and phosphoric acid. In this, which come under the strong acid category? HCl, okay, sulfuric acid and nitric acid. Now why do I call it as a strong acid? Now you can distinguish the acids as strong acids or weak acids based on their ionization in the water. Now I call something an acid when it dissociates and gives H plus in water, Now if the acid gets completely ionized, okay, now if the acid gets completely ionized, okay, what do I call it as? Strong acid. If an acid gets completely ionized in water and produce H plus, I call it as what? Strong acid. Now if an acid is partially ionized in water and produce only small amount of hydrogen ions, for example, if you take HCl, if you take 100 molecules of HCl, almost all the 100 molecules will dissociate and give H plus. If not 100, at least 98 to 99 molecules of HCl will dissociate and give H plus. So can I say here, in case of HCl, the percentage ionization is more? Okay, in case of HCl, the percentage ionization is more, or the degree of dissociation is more. More molecules of HCl are getting dissociated to give H plus ions. In the same way, if you take a weak acid, okay, no, if you can take your acetic acid, organic acid is a weak acid. Even in mineral acids, your carbonic acid and phosphoric acid are weak. Okay, only these 3 mineral acids are strong. Okay, and these two mineral acids we consider as weak acids only. See, mineral acids altogether are comparatively stronger than organic acids, but even in all organic acids are weak. In mineral acids, which two mineral acids are weak? Carbonic acid is weak and your phosphoric acid is weak. Now if I, in the same way, if I take 100 molecules of ethanoic acid or acetic acid, hardly you no hardly you have your 10 to 20 molecules of ethanoic acid undergoing dissociation to give H plus. So I can say here the degree of ionization is very much less. If you are taking 100 molecules, if it is HCl, almost all the molecules are getting dissociated or ionized to give H plus ions. But if you are taking a weak acid, very less number of molecules are getting dissociated to give H plus. So here in case of weak acids, I will call it as partial ionization. Okay, here I can call it as complete ionization. In strong acids, I call it as complete ionization. In partial acids, I call it as weak ionization. Clear? Okay. Okay, I hope you understood what, no, when do I consider it as strong acid and when do I consider it as a weak acid. Okay, this you have to remember. Dilution we will see later as a separate topic. Okay, now let us see what are bases. Okay, bases are bitter in taste. Okay, you can see here bases are bitter in taste. They have a soapy touch. Okay, when you touch them they have a very soapy touch. You know how do, no, how does this, how do you feel when you touch a soap? So it has the same soapy touch. They are bitter in taste, soapy touch, and they turn the red litmus paper into blue. Okay, they give hydroxide ions in the aqueous solution. Now, if I have to show in the form of diagram, if you take water in the beaker, okay, if you take water in the beaker and if you add a base into it, the base dissociates, giving which ions? If you take NaOH, it will dissociate and give Na plus and OH minus ions. So, okay, a base is something which will give hydroxide ions in the solution. If the base is giving hydroxide ions in the solution, what do I call it as? I call it as a base. Now, you can take few examples of bases. NaOH is a base. Okay, NaOH is sodium hydroxide, very commonly called as caustic soda, very important. NaOH common name is what? Caustic soda. Then you have your calcium hydroxide. Then you have your potassium hydroxide. The common name of potassium is caustic potash. Very, very, very important. Please remember these two common names because sometimes in questions they don't directly use sodium hydroxide and potassium hydroxide. They use the words caustic soda or caustic potash. Clear? Now bases, they are bitter in taste, they are soapy to touch, they turn the red litmus paper into blue, they conduct electricity in solution. I just now told you, okay, conduction in the solution is due to the formation of ions. Now here if you see, don't you have the ions? Yes, when the ions are there in the solution, they conduct electricity. So acids and bases, both of them, they conduct electricity because they, they lead to the formation of ions in water that will in turn conduct electricity. So acids and bases are very good conductors because they lead to the formation of ions. They release OH minus ions in the aqueous solution. This I have already mentioned you. Okay, now so we have classified acids. How did we classify acids? Based on their occurrence, we classified them into organic acids and mineral acids, and based on their percentage degree of dissociation or ionization, I have classified them into strong acids and weak acids. In the same way, bases can be divided into two types. What are the two types? I can classify bases into water soluble bases and water insoluble bases. Clear? Now, ma'am, no, you should be getting a dot. When do I call it as a water soluble base and when do I call it as a water insoluble base? I will tell you something. I think you have a basic idea of the periodic table. In the periodic table, you have the first group and the second group. Okay, groups are the vertical ones. Okay, groups are the vertical ones. In first group, I am not taking hydrogen here because hydrogen is not even a metal or non-metal. It's a different category. In the first group, you have lithium, sodium, potassium, rubidium, cesium. Okay, clear? Clear? Now all the first group, all of them are metals. They are called as alkali metals. Okay, the first group metals are called as alkali metals. Now if you come to the second group, okay, if you come to the second group, you have beryllium, okay, magnesium, okay, calcium, barium, strontium. Okay, calcium, okay, barium, strontium. Now all these elements, they are called as your alkaline earth metals. What do you call all these metals as? We call them as alkaline earth metals. So in the periodic table, in the first group you have these metals, in the second group you have these metals. The first group metals are called alkali metals, the second group metals are called as alkaline earth metals. Now when you take the hydroxides of these metals, if I take LiOH, if I take NiOH, NaOH, if I take KOH, if I take RbOH, if I take cesium hydroxide, All these are what? Hydroxides of alkali metals. Now for alkaline earth metals, if I take the hydroxides, okay, BeOH taken twice, MgOH taken twice, okay, CaOH taken twice, okay, barium hydroxide BaOH taken twice, strontium hydroxide SrOH taken twice. Now all these alkali earth metals hydroxides and alkali earth metals hydroxides, all of them are soluble in water. Okay, all of them. So which bases are soluble in water? The hydroxides of alkali metals and the hydroxides of alkaline earth metals, they are soluble in water. Now whenever the base is soluble in water, what do I call them as? Alkalis. So all the bases are not alkalis, only the completely water soluble bases are called alkalis. Again I am repeating, all the bases are not alkalis, only the first group and the second group metal hydroxides are called as alkalis because they are completely soluble in water. This is a very important question. The first group and the second group hydroxides are completely soluble in water. So those bases which are completely soluble in water, what do I call them as? Alkalis. Lithium hydroxide is an alkali. Magnesium hydroxide is an alkali. Copper hydroxide is not an alkali because copper does not belong to first and second group of periodic table. Then that is not an alkali, nor copper hydroxide is completely soluble in water. I hope you understood. You will not mess up in this part again. Okay, please, that is the reason I have written the elements also which are there in first group and second group, so that you don't do any mistake when it comes to the examination point of view. Now, okay, I have written here, for example, sodium hydroxide. This all I have explained. Now let us see now what are the indicators. Okay, see, I can't keep tasting everything. Okay, if someone asks you what is an acid, okay, is this an acid or base? Okay, if someone asks you, okay, if someone asks you, if particular compound is acid or base, now you can't keep on tasting everything and tell, no, you can't keep on tasting everything and tell that this is an acid and this is an base, because all the things are not edible. Okay, all the things are not edible. Then what do you need? You need an indicator. You need a substance which can indicate whether the given substance is acid or base, because you can't taste everything. No, okay, this is sour, this is acid, okay, this is bitter, this is base. I can't do that, right? So we need certain substances which are indicators, which indicate whether the compound is acid or basic, okay, by the color change. Okay, by the color change. Now the indicators are classified into three types. The first category is my natural indicators, which, okay, the second category is my synthetic or artificial indicators. Okay, synthetic means man-made. Okay, clear. And the last type is your, okay, other type is your olfactory indicator. So you have three types of indicators. Now when we come to natural indicators, indicators that are obtained from natural sources are called natural indicators. What are the examples of natural indicators? Litmus, turmeric, red cabbage, China rose are some, okay, very common natural indicators. Clear. Now the color, how do they do the color change? We'll see in the form of a table. Okay, that will be easy instead of learning it as theory. There is a table in the next page. There we will see what is the color change it shows in acid, what is the color change it shows in base, naturally what is its color. All those things we'll see in the table. Here we'll quickly see what are the natural indicators. Litmus is obtained from where? Lichens. Okay, lichens. And the solution of litmus is purple in color. Originally litmus is in which color? Purple in color. Next is turmeric. Turmeric is also a natural indicator. The natural color of turmeric is what? Yellow. Then you have your red cabbage. Now the juice of red cabbage is purple in color. So these are the natural colors. Litmus natural color is purple. Clear. Turmeric natural color is yellow, and red cabbage natural color is what? It is your purple. Okay, now we will see the next type of indicators. Now the color change of these indicators in acid and base, that we will see in the form of a table. Before that, we'll take a quick introduction of all the types of indicators. Then you have your olfactory indicators. Olfactory indicators are the indicators where you can tell that given substance is acid or base by smelling it. Okay, by smelling it. Now what are the major olfactory indicators you have, and how do the olfactory indicators act? Please check here. Substances which change their smell when mixed with acid or base. What happens to the olfactory indicators? They change their smell. If you put acid, if you put base, okay, there is some change in the smell. Okay, so they are called as olfactory indicators. Now the major examples are what? Onion and vanilla. You can take one more example here, which is your clove oil. I think it is mentioned in NCERT. Clear. Now what you will do, you take a paste of onion or you take juice of onion. Now if you are putting a base onto it, onion will lose its smell. If you are okay, if you are putting an acid, there is no change in smell. The same with vanilla extract. Okay, if you put base on it, the smell is lost. Okay, the vanilla extract loses its smell. But if you are putting acid onto it, the vanilla extract will not lose any smell. Okay, olfactory indicators are used to ensure the participation of visually impaired students in the laboratory. If you have visually impaired students in the laboratory, they can't use your color change indicators, no, because they can't see the change of color. So to those people, this will be very useful to determine whether it is an acid or base based on the smell. So these are your olfactory indicators. Now when it comes to synthetic indicators, synthetic means they are synthesized in the laboratory and we call them as synthetic indicators. What are the best examples we have in the syllabus for synthetic indicators? It is your phenolphthalein and it is your methyl orange. Phenolphthalein, naturally it is a colorless liquid. Okay, its originally it is colorless. Methyl orange, okay, its natural color is orange. Now we have seen the natural colors. Now in the next page in the table, let us see what are the color changes they do in acid and what are the color changes they do in the base. Okay, let us do that now. Okay, this table is very important for you. You have to remember the table. Okay, you have to remember the table. Now, if you see here, okay, one by one, let us see. Okay, if you see one by one, red litmus. Okay, red litmus original color is what? Okay, red litmus original color is your red. Obviously, it is red litmus, so the original color will be what? Red. Okay, in acid there is no change. Okay, red litmus paper, in base it will turn itself into blue. Then if you have a blue litmus paper with you, original color is blue. In acid, the blue litmus paper will change into red, and in base, blue litmus paper will not show any change. Clear? So lead litmus paper will turn into blue if it is okay, if it is an what if it is a base. Blue litmus paper will turn into red if it is an acid. Clear? Now turmeric, originally the turmeric color is yellow. In acid, it will remain yellow. There is no change in color. If it is a base, it will change into reddish brown. Okay, usually what do we do is we take a paper. Okay, we make a turmeric paste, and on the paper I will put the turmeric paste, and this will act as an indicator. Now put some acid, put the whichever you want to know, whether it's acid and base, put it on this turmeric paper. Okay, if the paper is still remaining yellow, then you say that the compound is acid. If the turmeric paper is turning red or maroonish color, then you can say that the compound is base. Clear? Now the red cabbage is original color is purple. In acid, the red cabbage will change into reddish, and in the base, the red cabbage will change into greenish yellow. Now the phenolphthalein, I already told you, phenolphthalein and methyl orange are very important. Very, very important. Originally phenolphthalein colorless. In acid, if you put some acid, if you put phenolphthalein in acid, phenolphthalein will remain, okay, phenolphthalein will remain colorless. But if you are putting phenolphthalein in base, then the phenolphthalein will change into pinks, so the whole solution will turn into pink. Then if you take methyl orange original color is orange. In acid, methyl orange will turn into red. In base, the methyl orange will turn into yellow. Okay, onion, original color, so we are not bothered here. But what happens if you put acid on onion? Okay, it will still smell onion smell only. But if you put a base on onion, the smell vanishes. The same with vanilla extract. If you put an acid into the vanilla extract, it will still smell as a vanilla extract. But if you put a base onto it, the smell will vanish. Okay, this is all about your all types of indicators you have to learn. Clear? Okay, now let us go down. Okay, now let us go down and study. Okay, let me take out the drawing so that it doesn't disturb your view. Clear? Okay, what are we doing next? Next, we are going to do the chemical reactions of acids. Okay, next we are going, this is very important. Usually questions come from this part. Okay, we'll see first chemical properties of acids, then we'll see the chemical properties of base. Okay, in this, the first chemical property is what? First chemical property of acid is what? Reaction of acids with metals. Okay, you people know acids can react with metals. Acids do react with metals. Okay, now, okay, please take care here. Please take care what happens here. When a metal reacts with acid, what will form? A salt will form, and which gas is released? Hydrogen gas is being released. Okay, when metal reacts with acid, salt and hydrogen gas is released. You can see an example here, zinc. It is zinc salt. Okay, here there is a mistake. It is zinc. Okay, zinc plus HCl gives ZnCl2 plus hydrogen gas. Okay, you can see what is this reaction. It is a simple displacement reaction. It is a simple displacement reaction. Now you people have to take care. In the reactivity series, if the metal is above hydrogen in the reactivity series, that metal will displace hydrogen from its acid. Okay, now if the metal is below hydrogen in the reactivity series, it cannot displace hydrogen from the acid. Now, instead of zinc here, if I take copper, this reaction will not happen because copper is below hydrogen in the reactivity series. Clear? Please take care of that. And what kind of reaction is this? This is a displacement reaction. And what gas is released here? Hydrogen gas is released. Now, you can see here next, hydrogen gas and sodium sulfate are formed when sulfuric acid reacts with sodium metal. Why only HCl? Don't we have other acids? Yes, we have other acids. Sodium plus H2SO4, when it reacts, what do you get? You get your sodium sulfate and you also get your hydrogen gas. So whenever metal reacts with acid, okay, what is released? A salt is formed, and along with the salt, what is released? Hydrogen gas is released, and these reactions are your simple displacement reactions. Now, if you test for the, how do you test for the hydrogen gas? Now, if the reaction is happening in a beaker, or if the reaction is happening in the test tube, and if hydrogen gas is getting released, how do you test it? You will take a burning splinter. Okay, you will take the burning splinter and you will bring the burning splinter near the mouth of the test tube. Okay, if the gas burns with a pop sound, okay, if the gas burns with a pop sound, you can bring a burning splinter, or you can bring just a lighted candle. Okay, if the gas burns with a pop sound, I will confirm that the gas released in this reaction is hydrogen gas. So what is the characteristic feature? If hydrogen gas is there, burning with pop sound is a characteristic test for hydrogen gas. If it is burning with pop sound, then I say that the, okay, hydrogen gas has been released in that particular reaction. Now let us see the next reaction here. Reaction of acids with metal carbonate. Now acids can react with metal carbonates because metal carbonates are basic in nature. Okay, metal carbonates are basic in nature. Okay, metal carbonates are basic in nature. Metal bicarbonates also are basic in nature. That is the reason metals can react with both. Clear? Acids can react. Okay, acids can react with both metal carbonates. Okay, acids can also react with metal bicarbonates. Why is this happening? Because both the metal carbonates and metal bicarbonates, they are basic in nature. Okay, clear? They are basic in nature. That is the reason acids can react with both metal carbonates and metal bicarbonates. Now, if you see the reaction here, okay, see very carefully, metal carbonate reacts with acid, and what it will give? Now, whenever a carbonate or bicarbonate is participating in any chemical reaction, whenever a carbonate or bicarbonate is participating in any chemical reaction, you will definitely see the release of carbon dioxide, because here what do you have? Carbonate. That is the reason definitely what do you get? Carbon dioxide. Because metal oxide is basic in nature and this is an acid, basic nature compound plus acid has to definitely give a salt, because acid plus base will give you salt. This is not a clear base, but it is a basic compound. So you will get a salt. Why are you getting carbon dioxide? Because carbonate is there. Why are you getting water? Ma'am, it is almost a neutralization reaction, because it is almost an acid and a basic compound reaction. Because it is an acid and basic compound reaction, salt you will definitely get, water you will definitely get. Why are you getting carbon dioxide here? Because I have carbonate in the compound. Okay, clear? You can see the reaction. Sodium carbonate plus 2HCl gives 2NaCl plus carbon dioxide plus H2O. Clear with this? Okay, all acids have to be written with the physical state of aqueous, because it is a soluble metal carbonate. I'll write it as aqueous. Okay, this is a soluble salt. I write it as aqueous. Because this is a gas, I'm writing it as gas. H2O is water, liquid, so I'm writing it as water. Be clear with the physical states in all the chemical reactions. If you are writing physical states wrong, it is a very big problem. Okay, I'll try to take a session on how to write the physical states of compounds in the reactions. All the acids and bases should be written as aqueous. All metals should be written as solids. All metal oxides should be written as solids. Okay, so whenever it is possible, I'll keep on telling it. Okay, I'll keep on telling it. Now you can see few more reactions. Now you can see few more reactions of metal carbonates here. Okay, so for more practice of yours, I have taken one more metal carbonate here. Calcium carbonate I am taking. If you see here, sodium carbonate I have written as aqueous, calcium carbonate I have written as solid. Why? Because calcium carbonate is not soluble in water, so I have written calcium carbonate as solid. Plus H2SO4, what do I get? It is almost a neutralization reaction. Calcium from here, sulfate from here. You get a salt, calcium sulfate. This is a soluble salt, so it is aqueous. I will get carbon dioxide and I'll get water. Okay, now you take HNO3 and sodium carbonate. Okay, NO3 from here, sodium from here, you get sodium nitrate. Now what is left here? H2CO3 is left. Okay, that H2CO3 is carbonic acid. Carbonic acid will break down. Okay, see, you get NaNO3 and you also get carbonic acid. That will break down into H2O plus CO2. The same case here. You get calcium sulfate plus carbonic acid. Carbonic acid will break down into these two. You get NaCl plus carbonic acid. It will break down into carbon dioxide and H2O. Clear with this? I hope it is clear. Okay, now you see here. Okay, acid can also react with hydrogen carbonates, bicarbonates. Okay, it can react with sodium bicarbonate. It can react with potassium bicarbonate. Now, what is the reaction here? Acid plus metal hydrogen carbonate, okay, will give salt plus calcium hydroxide plus water. Same as how the carbonates were giving salt plus calcium, carbon dioxide plus water. In the same way, when the reaction is with metal hydrogen carbonate, also it will give salt plus carbon dioxide plus water. Clear with this? Okay, now we will see the reactions here. What are the possible reactions and how, okay, how do you need to understand the reactions of acid with sodium hydrogen carbonate. Now you can see here sodium bicarbonate is reacting with H2SO4 giving sodium chloride, calcium carbon dioxide and water. It is almost similar to the previous reaction, am I right? It is, the products are similar to the reaction of carbonates with acid only, but the only difference is there you take 1 mole of carbonate, 1 mole of carbonate. Okay, here I am taking 2 moles of bicarbonate. That is the only difference. Remaining everything will remain the same. Now in this reactions, in both the reactions of sodium carbonate with acid and in the reaction of sodium bicarbonate with acid, what is the gas being produced? Carbon dioxide gas. Now we have to test for the evolution of carbon dioxide gas. In the first category of the chemical properties of acids, we did reaction of acids with metals. In that, hydrogen gas was getting released, so I was testing for hydrogen gas. In this case, carbon dioxide gas is released, so I am testing it for carbon dioxide gas. Now what do? In the reaction, which gas is released? We are believing carbon dioxide gas. Now you will send this carbon dioxide into lime water. What is your lime water? It is a solution of your calcium oxide. Okay, calcium oxide is slaked lime. When you make a solution of this slaked lime with water, what will happen? This I call it as lime water. Lime water is basically a solution of calcium hydroxide in water. Okay, now when you pass carbon dioxide into this lime water, what do you get? You get a milky white precipitate, which is due to the formation of your calcium carbonate, and you also get water. Clear? You get a milky white precipitate here, which is your calcium carbonate. Now when you pass excess carbon dioxide, what will happen? The excess carbon dioxide, okay, excess carbon dioxide along with some water will react with this milky white PPT calcium carbonate, no, giving calcium hydrogen carbonate. Now, initially when you added CO2, you had a milky white precipitate. Now, when you add excess of CO2, what is formed in the solution? You get sodium bicarbonate in the solution. Now, sodium bicarbonate is soluble in water. Okay, clear? So, when you pass limited carbon dioxide, you get calcium carbonate, which is a white PPT. Now, when you send excess carbon dioxide, what will happen? Okay, the formation of calcium bicarbonate or calcium hydrogen carbonate takes place, which is a soluble salt, so you get a clear solution. Clear? Limited CO2, calcium carbonate, white PPT. Excess CO2, calcium bicarbonate is formed, which is a soluble compound. So you will get a clear solution. Very important. This is limited CO2, white PPT. Excess CO2, you get a clear solution due to the formation of soluble calcium bicarbonate. Please remember this. This is very, 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 very important. Okay, now let us see the next part here. Okay, okay, what is common in acids? What do you commonly see in acids? Okay, now here what did we see in the chemical reactions of acids? What did you observe in the chemical reactions of acids? That acids give hydrogen gas when they react with the metal. What are they giving? Acids give hydrogen gas when they react with the metal. What does this prove? What does this prove? This proves that all acids have hydrogen. It is proving that what? If acids on reaction with metal are giving hydrogen, doesn't it prove that all the acids should have what? All the acids should have hydrogen. Clear? And that hydrogen is in the form of what? H plus. Clear? Okay, the dissociation of hydrogen ion in aqueous solution is the common property in all acids. In all the acids, what is the common property I have observed? In all the acids, the common property I have observed is the release of H plus. Clear? Now, when HCl is decomposed, you get H plus Cl minus. Here you are seeing H plus. Even when you take your weak acid, when it dissociate, it is giving you acetate ion and H plus. So, what is commonly seen in any acid? commonly seen in any acid is release of your H plus, which is your hydrogen ion, which is your hydrogen ion. Now, how did we even think, assume that there might be hydrogen in the acid? Because acids on reaction with metal were giving hydrogen gas. So with the assumption that they might be having hydrogen, we have gone with the thing, and we have done our experiments, and we clearly proved that okay, acids when they dissociate, they release H plus in the water. Clear? Now we are going to see the chemical properties of bases. Still chemical properties of bases we'll see in this session, and the next part, okay, pH, about NaCl and compounds from NaCl, water of crystallization, and all that we'll see in the second part in the next video. Now if you see here chemical properties of bases, if you see here, it is very important to understand the chemical properties of bases. When you are doing the chemical properties of bases, usually, now listen here very carefully, all metals do not react with bases. Okay, metals usually don't react with bases. Okay, because metals are also slightly basic in nature. Metals are also slightly basic in nature. All metals don't react with bases. There are certain metals, few metals which react with bases. They are your zinc and aluminum. Usually metals don't react with bases because metals basically are basic in nature. Okay, now you have two metals. Basically, in grade 10 we take two metals, and these two metals we are calling it them as amphoteric metals. Now because they are amphoteric metals, they can react with both acid, okay, they can react with both acid, and they can also react with base. Usually no, if it is a normal metal, you take some metal, okay, you take some metal, sodium. If it is a normal metal, okay, if it, normally 98%, 99% of the metals, they only react with acid because metals are basically basic in nature. Clear? But there are certain metals, okay, which are amphoteric. Means what? Okay, they can react even with acid. See, reacting with acid is a normal property of metals, but they can also react with the base. Clear with this? Okay, now what are those metals which react with both acid and base? Zinc and aluminum. Now if you see here, see, zinc plus HCl reaction, you already know that, we have already seen. So zinc reacting with HCl is very common, but zinc can also react with what? Sodium hydroxide. Zinc can also react with sodium hydroxide, giving what? Sodium zincate. Now if you want the ions in sodium zincate, Na plus and ZnO2 2 minus. Okay, this is your sodium ion, this is your zincate ion. Together they form sodium zincate, which is a salt, and you also see the release of hydrogen gas. Whether the metal is reacting with acid or whether the metal is reacting with base, what is the common thing you see here? The release of the hydrogen gas. I also told aluminum also is an amphoteric metal. Reacting with acids is common, but aluminum can also react with base, and with little amount of water, what is formed here? Sodium aluminate, or sometimes it is also written as sodium meta-aluminate. Both of them are same, and you also see the release of what? Hydrogen gas here. Okay, and you also see the release of what? Hydrogen gas here. Clear with this? This is your sodium aluminate. If you want the ions here, Na plus sodium ion, and AlO2 minus is your aluminate ion. They together form sodium aluminate. So what are the two metals that react both with acids and bases? Your zinc and aluminum. Normally all other metals react only with acids because these both are amphoteric metals. They react with both acids and bases. Clear? Hope this is clear for you. Next we will see the reaction of base with, okay, next we will see what? Reaction of base with oxides of non-metals. Now this is very important. Okay, this is very important. Listen very carefully. I'll explain you something here. Listen very carefully. Okay, with this topic we'll end this session, because acids and bases revision I'm doing in two videos. This is the first video. In the next video, when I upload, you will have the other part of acids and bases. Now if you see a base and if you see an acid, okay, bases will react with non-metal oxides. Clear? Bases react with non-metal oxides, and acids react with metal oxides, and acids react with metal oxides. Okay, clear? Because if you are getting a doubt why non-metal oxides are acidic in nature, metal oxides are basic in nature, this question has been asked many times in the board exam, so please take care. Non-metal oxides are acidic in nature, metal oxides are basic in nature. Now base will obviously react with non-metal oxides only because they are acidic in nature. A base cannot react with metal oxide, no, because metal oxide also is basic in nature. When the base will react with non-metal oxide, acid will react with metal oxide because metal oxides are basic in nature. Clear? So base reacts with non-metal oxide, acid reacts with the metal oxide. Okay, let us see the reactions for this. Okay, let us see the reactions for this. Now you have the reactions here. You have the reactions here. Please see here. What is happening here? You have a base in front of you, which is your sodium hydroxide, Now sodium hydroxide, as it is a base, it will react with non-metal oxide, because non-metal oxides are acidic in nature, and form what? Sodium carbonate plus water. So it is almost a base plus acidic compound reaction. So definitely you will have the formation of water, and you also have the formation of sodium carbonate. So when a base is dissolved in carbon dioxide, you get your carbonate. In the same way, calcium hydroxide is dissolved in carbon dioxide. What are you getting? Your calcium carbonate. Along with that, you also get your water. So whenever your bases react with your non-metal oxides, you get your, if it is carbon dioxide, you get your carbonate. Now if it is your, okay, let's see here, if it is your sulfur dioxide also is a non-metal oxide, then what do you get here? You get Na2SO3 plus H2O. Now you can also try with SO3. SO3 also is a non-metal oxide. Sodium hydroxide plus non-metal oxide will give you what? Na2SO4, okay, plus H2O. It is not like that it reacts with only calcium carbon dioxide. It can also react with SO2, giving sodium sulfite. Okay, sodium sulfite. Okay, sodium sulfite, NO2, Na2CO3, sodium sulfite. It can also react with SO3, giving your sodium sulfate. So not only with carbon dioxide, sometimes they can ask with SO2, then you will write it is sodium sulfite. If it is with SO3, it is sodium sulfate. You can do the same with calcium hydroxide. No, calcium hydroxide, if it is reacting with SO2, what does it give? Okay, what does it give? It will give your, okay, CaSO3. Okay, if it is reacting with sulfur trioxide, it will give you a calcium sulfate. So don't by heart the things. If any gas they might give, which is a non-metal oxide, because non-metal oxides are usually gases. Okay, so they might give you CO2, then you write the formation of carbonate. If they give SO2, write the formation of sulfite. If they give SO3, write the formation of sulfate. Okay, so please don't by heart the things. Okay, when I do the PYQs part, I'll show you how the questions are asked from these parts. Okay, from these parts. Now if you see here, okay, now we have seen acids. Okay, now let me complete one more thing. I already told you that, no, okay, acids react with metal oxides. Okay, I have already told that acids react with metal oxides, right? Because acids are basic in nature. Acids are acidic in nature, and metal oxides are basic in nature. Acids can react with metal oxides. Okay, now see here, what will happen when acid reacts with metal oxide? You get salt plus water. Okay, clear? What was happening when base reacts with non-metal oxide? There also you are getting salt plus water. Clear? Now you have acid. Now this is a basic compound. Metal oxides are basic compounds. So definitely you will get water. Okay, you will get a salt here. Okay, you will get a salt plus you will get water. Okay, plus you will get water. You can take any metal oxide for that case. You can take HCl and any other metal oxide. Okay, you can take HCl plus MgO. What are you going to get there? You will get MgCl2 plus water. Like that you can take anything. Or if you want to take H2SO4, also you take H2SO4 plus MgO. What does it give? It gives your magnesium sulfate. You write the respective salt plus water. Okay, so you can do it with any acid. Whenever it is reacting with metal oxide, it has to give the respective salt plus water. So this is the reaction of base with non-metal oxides and reaction of acids with your metal oxides. Now you know what is neutralization reaction. With this will be done with the chemical properties of acids and bases, and the remaining part of the chapter, pH and everything, will be done in the next video. Now what are neutralization reactions? Okay, you know what are neutralization. This is such an important easy task for you. Okay, what are neutralization reactions? When an acid and base react, I get salt and water. Okay, when acid and base reacts and when you get salt and water, what do I call this kind of reactions as neutralization reactions? Because acid and base, when they combine, they neutralize and they form salt plus water. You can take HCl plus calcium hydroxide, acid plus base, they will give you salt plus water. Done. So this is all about the today's session. We have done almost half of the chapter, more than half of the chapter. The remaining half of the chapter we'll be doing in the next session. Very important. That session also is going to be. Please don't miss that session. Keep loving our channel. I'll give you the best revision for the boards. I'll see you in the next part of the revision video for the chapter acids, bases and salts. Till then, this is your Kirti ma'am signing off. I'll be seeing you in the next session for acid, bases and salts as a part of class 10 board revision. Till then, bye.